Okay, so in the previous video, I looked at example 1 as well as example 2. In this one, I'm just going to look at example 3 and then 4 and 5, the remaining examples. Okay, they say here we must solve this inequality. It's a quadratic inequality again. Okay, so let me just write it down. It says x plus 1 into x minus 3 bigger than 12. Okay, now when you look at this here, ladies and gentlemen, you see that it's not in standard form. According to our procedure, make sure that the inequality is in standard form, the quadratic is in standard form. So what are we going to do? We're just going to remove the brackets. X multiplied by x, it's what? X squared. X times negative 3 gives us negative 3x. This gives us a plus x. And then 1 times negative 3 is negative 3. That is bigger than 12. Okay, so we can therefore say that x squared, then we add these two like times, okay, minus 2x, then minus 3, and then we can subtract 12 on both sides so that it becomes minus 12 greater than 0, because we always want a 0 on the right of the inequality side. Okay, so therefore we just have x squared minus 2x minus 3 minus 12, it's minus 15 less than or equals to 0. Okay, then we have it in this standard form here. But is it factorized? No, when you look at it, it's not factorized. So you must factorize it ourselves. Okay, so we must factorize it ourselves. So we're going to say x as well as x, and then 5 as well as 3, negative, positive. Just remember how to just go back to the videos where you factorize quadratics. Okay, just watch videos how to factorize quadratic. Okay, you say the factors of x squared, x and x, two numbers that when you multiply them, they give me a 15, and when you subtract them, they give me a 2, 5 and 3, because 5 multiplied by 3 is 15, 5 minus 3 is 2. Then you write them down. Then the sign of the middle term goes to the bigger number, and then you just have to determine the other sign depending on what is the last sign there. Okay, then after this, you don't say x minus 5 less than or equal to 0 or x plus 3 less than or equal to 0. You say critical values. Critical values. Okay, then you say you just take each bracket, make it equals to 0. Solve for x, you get x equals to 5. Take the other bracket, x plus 3 equals to 0. And then you get x equals to negative 3. Okay, after having your two critical values, you can see you've got two critical values that are not the same. So what do? We just draw a number line. A number line, and then you look, does it include? Yes. So we're going to shade when you indicate it on the number line. So the number line is going to be shaded here. Okay, the smaller critical value on the left, minus 3, the bigger critical value on the right, 5, and we shaded there. Okay, then 3 regions, the values to the left of this one, this is the first region, and then the second region is these values that are between here, this is the second region. Values that are to the right of 5, this is the third region. Okay, so we have 3 regions. The moment you have two critical values that are different, you're going to have 3 regions. But the moment you have 2 critical values that are the same, or basically just one critical value, is going to be only 2 regions. The values that are to the left of that critical value and the values that are to the right of that critical value. Then we pick a value in each region. Pick a value in each region. Values that are to the left of minus 3, we can pick minus 4. We come back to this factorized version. We just substitute. Thought about that. Wherever you see x, you just put that minus 5. Okay, so we can get negative 9 times negative 1. So we get a positive 9. The sign is what we're interested in. We just put plus. Then we come to the second region here in between. Any value between minus 3 and 5, we can pick 3. Let's just pick 3. You can pick any value that you want. Any value in between the two, you can just pick any that you want. So in this case, I'm just going to pick 3. Okay, so when I put 3, it means wherever you see x here in this factorize, I'm just going to put 3. So 3 minus 5 into 3 plus 3. So it's going to give us negative 2 by 6, which is negative 12. The sign is what I'm interested in, negative. If you pick any value that are to the right of 5, we can pick 6. If you put 6 here, 6 minus 5, it's 1. 6 plus 3 is 9. So you get a positive. Okay, then you go back to your inequality sign. Please don't always choose the solution where it's positive. Look at go back to the factorization part here. Okay, here, this step here. Look at this. It says less than. Less than means negative. Don't go and pick and write the solutions to intervals that are what? That are positive. You must look there. It says less than 0. Okay? It says less than 0. Sorry about that. It says less than 0. So when it says less than 0, it means we want to go write a solution in the region that is a negative. This one, we're going to minus it because it's positive. This one, tick. this one minus. Okay, so our solution is between -3 and 5. It's in this region here. How do we write it down? You just say, therefore, you put x in between, the x in between, and then you put the two values there, -3 as well as 5, and then you just do this. You just put the inequalities in between. And also remember the inclusion underneath the inequality signs, because the original problem also included. And then you are done. This is how you write down the solution. It's between -3 and 5. -3 on the left side, 5 on the right side. Okay, that is the solution to this inequality here. Oh, I made a mistake here. If you see I made a mistake. Our original problem had a greater than. I made a mistake. Sorry about that. Which means the solution to this, the actual solution to this is going to be, we're going to pick the positive. But if it's negative, if we want to get the negative, that's how you write down the solution, provided that the solution was in between there. But we are going to pick this, and then we're going to minus this. So we're going to have our solution as x. We point to the direction of the first region because we are picking it, -3, or x bigger than or equals to the direction of the bigger one, which is 5, which is on the third region. So this is our solution. But that solution will only work if our inequality was like this. It was a mistake from my side. Okay, I made a mistake with the sign. It was supposed to be bigger than 0. Okay, so this is the solution to this. But if it was negative, that's how we'll put it. Okay, so if you look at this example here, this is another example 4. So in example 4, the first thing you see, you just make it in standard form, minus this, minus 15, less or equals to 0. And if you look at this, it factorizes the same as that one. So it's -5 x plus 3 less or equals to 0. Now you get now if you look at your critical values, your CVs, x minus 5 equals to 0, your x equals to 5. Or you can say your x plus 3 equals to 0, your x equals to -3. Okay, and then when you look at this, you can see that in your number line, you're going to have what? The -3 as well as the 5. But then the only difference with the two problems is that this one has a less than or equals to, and this one here, it had a greater than. So the solution that I had initially here, that one that I had initially here, this one, it's actually going to be the solution to this one if you try to test it. Okay, you see that was the only difference. So if you do it the same way, you'll get that the solution is actually this one for the second problem here. Okay, I'm not going to really finish it, but you can try it on your own. This one is the same, more or less the same problem. Okay, let's do the last one, which is example 5. Okay, example 5, again, you must make it standard form. So we have x minus 1 into x minus 4 bigger than the x plus 11. Okay, so you just remove the brackets, x times x, it's x squared, x times -4, -4x minus x plus 4 here, minus another x minus 11 greater than 0. You're just getting it in the standard form that you're used to. Therefore, your x squared minus the 6x, because minus 5x minus x minus 6x, and 4 minus 11 minus 7 bigger than 0. Okay, is it? Yes. Then you factorize now to get your critical values. Okay, then you're going to factorize. So you're going to have x and x, 7 and 1, negative and a positive. Okay, let's make sure you know how to factorize that. Then you get your what? Your critical values. The critical values is going to be x minus 7 equals to 0. The second one, x plus 1 equals to 0. So if you solve, you get x equals to 7, here you get x equals to -1. Then you draw your number line. It's more or less the same thing, doesn't change. You put your 2, you can see the problem does not include. So if it does not include, you don't shade, you put them as open circles, smaller critical value on the left, bigger critical value on the right. Then you have your 3 regions. First region, your second region, and then your third region. Choose any value in each region. -2, if you put -2 here, you get -9, -1. So you get a plus here, and if you test here, you'll see you get a minus there in between, and then here you get a plus. Okay, you get a plus there. So if you see that the region that we're interested in is the plus, so we're interested in the positive, so we're interested in this region as well as that region. This one we are not. Okay, so our solution is going to be, therefore your x is going to point in the direction of the smaller one, or your x is going to be to the right of 7. Okay, this is the solution to this problem. Okay, I hope you can see the way I did all of these problems in this quadratic inequalities section. Okay, and in this ones, it's just a matter of understanding the procedure. That's actually how the number line method works. Okay, and if you look down there, I've got homework problems that you can also try by yourself. Okay, try by yourself there to make sure that you actually understand the concept of quadratic inequalities. The first one is this one. You've been given x squared minus x minus 20 is less than 0. Solve for x if it's less than 0. The second one is to solve for x if x squared minus 4x is less than or equals to 21. Then the third one and the fourth one, I just wrote them down, is this one, x squared plus 7x plus 10 is greater than 0. And then the last one is this one here. Okay, for 3 marks. Those are the homework problems you can actually try applying the concepts that we've just looked at in this video. Okay, I hope it makes sense, and if you have any questions, you can just post them in the comment section. Thank you very much.